Hello friends, this is Durga again from ITversity, a one-stop shop to learn all the technologies. At this time we are talking about setting up single node Cloudera cluster to practice Hadoop and Spark as a developer. So we have deployed all these services: HBase, HDFS, Hive, Hue, Impala, Woozy, Spark, etc. So as part of this video we will review as many as tools in this video, so that we make sure that it works as expected. If you see, one of the service HDFS is red in color, and if you click on this you can see the issue. It is complaining about under replicated blocks. So replication factor is the way Hadoop handles the fault tolerance of the data. So the data or the files which have the data will be divided into blocks, and those blocks will be distributed on multiple nodes in the cluster in case we have multi-node cluster. And also for the fault tolerance, if one of the nodes goes down, to actually retrieve the data, HDFS actually use a concept called replication factor, where each of these blocks associated with file have multiple copies of it, and the default replication factor is 3. In this case, as we have only one node, it will have only one copy instead of 3 copies. Hence you will see this error under replicated blocks, which we can suppress on our lab, okay, so that this misleading error will not pop up in future. So once it is suppressed, it will turn green. Now we will actually validate all the services in this single node cluster. For that we have to log into command prompt, and here you can run HDFS commands such as Hadoop fs -ls to list what all directories are created so far. So there is a directory called user, and in that there are directories such as history, Hive, Hue, Spark, etc. And also what we'll do is, to simulate our Cloudera Quickstart VM, we'll create a new user called Cloudera, okay, and then we will set the password for Cloudera. Password will be Cloudera itself, okay, and then to enable no need to worry. Once you log in as root onto the host, now you can actually say sudo su Cloudera, and you can connect as Cloudera on this host, okay. So first we will create a user space for user Cloudera. Once we create OS user called Cloudera, we can create a user space for this user in HDFS, which means that we need to create a directory called Cloudera /user, and the owner is also should be Cloudera, okay. Once we have a directory called Cloudera under user and also the owner as Cloudera, that means we have a user space for Cloudera in HDFS. Here I will not get into too many details about what is HDFS, what is YARN, etc. Those things will be covered as part of the main course of Hadoop. This is primarily to set up the lab for practice as a developer, okay. So now what you can do is, you can run this command called sudo -u HDFS Hadoop fs mkdir, because first we need to create a directory. To create a directory we can use the command called -mkdir under Hadoop fs, and also we are using sudo -u HDFS because HDFS is the owner of Hadoop distributed file system. So this HDFS is the owner name. So we are actually running this command Hadoop fs -mkdir user /Cloudera as HDFS. So the user will be means whatever permissions are there for HDFS user will be inherited to this command. Now once you hit enter, it will create the directory, and you can review that by running this command Hadoop fs -ls /user. You will see the directory Cloudera in it, but the owner is HDFS, and we have to change this owner to Cloudera so that Cloudera have the user space to copy files to that location. For that again you have to run sudo -u HDFS Hadoop fs ch1 Cloudera is the owner which we want to change to, and then user Cloudera, and hit enter. Now the owner is changed. You can again review by running sudo Hadoop fs -ls /user, and you can see now the user space is Cloudera. So now we will use Cloudera user to perform most of the tasks on this lab. So for that you can do sudo su -Cloudera and hit enter, and we can access user Cloudera as Cloudera user. So user /Cloudera in HDFS as Cloudera user. There is nothing as of now. So first we will just create an empty file. Touch is a Linux based command to create empty file testing, and then we will say Hadoop fs -put testing, which is the local file, to HDFS, and hit enter. And then Hadoop fs -ls user Cloudera, you will see a file called testing here. And then there is a file called there is a jar file using which we can actually run the MapReduce job. Okay, so what I will do is I will actually add the Cloudera user to sudoers. Okay, so the way you can add it to sudoers is by copying this command. Okay, so Cloudera have become sudo now. So now you can actually do sudo su Cloudera, and now you can actually run sudo ls-root. Typically you will not be able to access this one, but now you are able to access because Cloudera is capable of running sudo commands. So now Cloudera has become sudo after modifying this vi sudo file. So here what we will do is we will search for a file called Hadoop examples.jar. So sudo find, will be searching from the root directory. So find is a command in Linux to search a file following a pattern. So from the root directory, using name Hadoop *examples*.jar, and hit enter, and you can see multiple Hadoop MapReduce examples here. We will pick one of them and we will test it that it works as expected. That means the MapReduce jobs can be submitted on this single node VM. Okay, so copy this file and then Hadoop jar, use this jar file name, and then there is a program called random text writer, which will generate 10 GB data for each node in the cluster. As we have a single node VM, it will actually generate 10 GB test data on this server, random text writer, and the path to which the random text has to be generated is user Cloudera. Okay, Hadoop jar, and pick one of these MapReduce examples. Don't pick this one, it uses old API and you can run into issues. Make sure you pick this one, Hadoop MapReduce examples. Okay, and then random text writer is one of the application in the jar file, and /user/Cloudera is the path to which this random text will be generated to. So now it is actually connecting to resource manager, and it will try to run the MapReduce job in a moment. Okay, the output path is not correct. We should give a subdirectory under user Cloudera. We have to give the path which does not exist, so that it can actually create that path. So here I am creating random So here I am giving the path as user Cloudera random text writer, so that it will not fail again. Last time it failed because we have given the directory which is already existing. When you actually submit MapReduce jobs, typically you have to pass the output path which does not exist already. So it will create a directory called random text writer, and then it will actually copy the data over there. And now it will generate a URL here. Okay. So to use this URL, because it is using private IP, what we have to do is you have to enable SSH tunneling. Okay. So for that, you can open a new tab and SSH -i, give the path of our PEM file. Once you give the path of our PEM file, you have to use -N D 8157 as port number, and then root at the public DNS here and hit enter. So once you run this command with the -N D port number 8157, it will hang. As long as it hangs, you can actually do SSH tunneling and Foxy proxy. So if you want to understand what is Foxy proxy and what is SSH tunneling, again you have to go to my channel. There is a playlist called Amazon Web Services, in which I have covered SSH tunneling and Foxy proxy. So make sure you watch those videos, which is already covered on my channel to use Foxy proxy. Okay, so go to my channel. Click here, Amazon Web Services, and hit enter. Go to this playlist. There is SSH tunneling and Foxy proxy. You have to follow this video. So once SSH tunneling is running like this, then you can go to tools, go to Foxy proxy standard, and click on use EMR SOX proxy, which we have set up by following this video. Okay. Once the Foxy proxy is running, you can go back to this, get this URL, and run it here to see what is going on while the job is running. Okay, it is still unassigned. Probably it might take little time to get assigned. Let's see. Okay, it should not take this long. It seems to be that there is some issue. That's why it is taking very long time. Let's wait for some more time. Probably the random text writer is too big for this cluster. So I am killing this one. There is another program called word count. So I will just create a file, VI words, okay, and then run hello world and have multiple lines of hello world in this. Save it and come out, and then go to Hadoop jar command. Sorry, before going into Hadoop jar command, we have to copy this file, Hadoop fs -put words user Cloudera. So it will copy this file called words to user Cloudera directory, and now we will run Hadoop jar command. Here we have to say word count. This is the application which we are trying to run. We have to give the input path, which is user Cloudera words, and the output path. We have to create a new directory because earlier we abruptly stopped this, so the directory might already be there. So in this case, I will create a directory called word count here and hit enter. Now it is running. Let's see whether it will run, or again will there be any issue with this. So you can copy this URL, go here, Yeah, it is also still in the same state. So there is some issue running the MapReduce jobs uh, on this single node cluster with the current setup. So jobs are being struck. I think it is related to some memory settings which we need to customize when we set up smaller clusters. I have troubleshooted the issue. Now I will try to fix that issue. We have to allocate memory when for something called map and reduce containers, which I will be taking care of it now, and then we will restart the cluster and then we will test it. So we need to change container memory settings. Here you can see this MapReduce map memory MB, MapReduce reduce memory MB is 0 gigabytes. We have to change it to the default value, which is 1 gigabyte. Okay. If it is 0 gigabyte, it has to allocate by itself, but in smaller clusters there is a bug, I think, and it's actually make the job struck. So let us save it and then restart the cluster, and we will see whether we will be able to run those jobs which we tried to run yesterday and which got struck. Again, we will try with the random text writer, and we will see whether it works or not. So whenever you change the configurations, you have to restart if this icon comes up. So click on this one and take whatever actions it suggests. It says restart tail services, and then make sure redeploy client configuration is enabled, and then restart the cluster. You can expand this and see what all components are being stopped and started here. So Huey stopped, and then Hive is being stopped. Like that, it has to stop all the services which are dependent on YARN, and it has to start everything. So it will take a while. So now the services are up and running. Let me try running the jobs again. So also after changing those two parameters of container memory, I have also changed the node manager memory settings. So go to configuration and search for node manager memory. And if you scroll down, there is this YARN node manager resource memory MB, which was set to 1 GB by Cloudera when we actually set up the cluster. I have replaced to 8 GB. So I have changed overall 3 parameters. One is YARN node manager resource memory MB. It was 1 GB, and now it is changed to 8 GB. Okay, and on top of that, also I have changed the MapReduce map memory MB to 1 GB each. And then I restarted the MapReduce job, and it worked without any issues. Now let me run another job to make sure it works. So Hadoop fs-rm. I am trying to delete random text writer directory, and then I will rerun the random text writer, which will take some time and generate 10 GB of data. Okay, the application name which I want to run is random text writer. This is also part of this Hadoop MapReduce examples.jar. It takes only one parameter, which is the output path into which the 10 GB data has to be generated. and the directory name I will be giving is random text writer, and hit enter. Now it is starting another job which will generate this 10 GB worth of data in the target directory user Cloudera random text writer, and if you see, it is working. It will take a while, so I will pause until then, and I will review the other components in the Hadoop cluster as part of this another video. So now the job has ran successfully. You can see it here. So we have tested HDFS by creating a directory and copying into the directory, and then we have ran this MapReduce job, which to confirm that it is running. We ran into some issues of jobs being stuck on smaller cluster, and we end up changing a few memory parameters, after which it is working as expected. Okay, so that's being said, we will try to cover rest of the tools such as Hive, Pig, Scoop, Spark, etc. as part of the subsequent video. And if you like this video, or if you want to provide the feedback, please do so that I can improvise on my content. And finally, if you are not part of my LinkedIn groups such as ITversity-Big Data or ITversity-Certifications, please join, and we will discuss further about the topics, and I will try to come up with more and more content like this over time. Thank you. Bye.